Welcome to the deep dive. Grab your notes, your articles, your research, because today we are plunging headfirst into a topic that came directly from one of you, a listener curious about the fascinating and sometimes mysterious world at the frontier of water science.
We've got a really deep stack of source material here. I mean, it covers everything from the absolutely established fundamental science of HO
Right.
all the way through to some truly pioneering research and, yeah, some pretty unconventional theories about what water is and, what it might be capable of.
So our mission today is to navigate these waters, the well-known and the, let's say, deeply debated, to pull out the most important insights, help you understand the different claims being made, maybe explore what next-generation water systems could potentially look like.
Exactly. We're going to look at claims about water having structure, carrying energy, influencing biology in surprising ways. It's definitely a field that's sparking both excitement and, well, it's fair to say significant scientific skepticism.
Okay, let's unpack those.
Absolutely. And the only place to start, really, is with the rock-solid foundation. What do we know for sure about H2O? The universal solvent, essential for life.
It's that bent molecule, right? The V shape, oxygen with two hydrogens, and its unique properties, high heat capacity, surface tension, dissolving power, they all come back to its structure and those hydrogen bonds connecting the molecules.
Exactly. And this is the crucial point for our deep dive today. In liquid water, those hydrogen bonds are incredibly dynamic. They're constantly breaking and reforming.
Not slowly either.
No, not in seconds or milliseconds, but in femtoseconds, we're talking fractions of a trillionth of a second. This constant rapid rearrangement is why liquid water, under normal conditions, doesn't form or hold a stable, rigid, macroscopic structure.
So this fundamental understanding that water is dynamically unstable at a structural level, that's the essential benchmark.
It is. It absolutely is. Any claim that water can somehow maintain a stable, unique structure, especially one that lasts for minutes or hours or, longer, it has an extraordinary burden of proof against this established understanding. It really highlights just how radical some of the theories we'll discuss actually are.
And beyond structure, we know water is just, well, deeply integrated into biological processes too.
Oh, absolutely. It's not just a passive carrier molecule. It's actively involved in fundamental biochemical reactions like building things up, condensation, and breaking them down, hydrolysis, the molecules of life.
And the solvent thing is key.
Paramount. Its incredible solvability is essential for transporting everything, nutrients, enzymes, hormones, waste products throughout the body. It's the medium for, well, basically everything cellular.
Okay, so that's our baseline. Dynamic, essential H2O. Now let's venture into the concept that's driving a lot of the frontier research our sources cover, alive waters.
Right, and you should think of alive water as kind of an umbrella term. It covers various concepts like structured water, coherent water, functional water.
So not just one thing.
Definitely not. Our sources note that the terminology isn't really unified and the proposed mechanisms vary wildly. I mean, from specific molecular arrangements all the way to quantum coherence, energy patterns, electromagnetic alterations. It's not a single coherent idea itself, ironically.
It sounds like it represents a shift then from just cleaning water, purifying it, to actively trying to optimize it for biological benefit.
Precisely. That's the core idea. It's about exploring how water's interaction with living systems might be enhanced beyond simple hydration or just contaminant removal.
Let's look at some of the pioneers in this field then and their specific approaches, pulling from the source material. First up, Eric Laraker and his work with coherent water, leading to amelemma.
Okay. Sources describe Laraker's view that water is, well, profoundly mysterious. He sees it as a broadband absorber of frequencies.
Like an antenna.
Sort of, yeah. A medium that receives and transmits information, almost like a radio, where pure water supposedly conveys clearer information. He even connects this idea to chronic diseases maybe being seen as informational imbalances sometimes.
So coherence for him isn't just about a static physical structure then.
No, not solely. It's described more as enabling water to carry and transmit these subtle, energetic, or informational patterns. Amelemma water is presented as the result of, I think, 12 years of his research, undergoing this year-long physical process.
A whole year?
Yeah, a year-long process mimicking nature, apparently, to achieve what they call a powerful, coherent state.
And the sources mention this water is reported to maintain stability for up to 8 months. That seems Significant, if true.
Yeah.
Crucial for practical applications.
Yes, stability is absolutely key for any practical use. Laraker is quoted calling this conscious water, suggesting it acts as a kind of bioquantum computer, receiving information from the quantum field, which is deemed highly beneficial.
The source material includes some reported biological effects from studies mentioned, right? Some pretty interesting findings listed.
That's right, yeah. Reported effects include increased cellular energy, specifically ATP, the energy currency of your cells. Studies also report things like revitalized immune systems, boosted anti-inflammatory pathways, and improved gut health.
I noticed a mention of a double-blind, placebo-controlled study on gut health. That sounds like a more conventional, rigorous design than you might expect in this area sometimes.
It does. The source mentions a study involving, I think it was 16 healthy adults over 3 months. It reported a significant average improvement in gut dysbiosis scores and suggested a protective effect against pathogens, showing clear improvement over the placebo group.
Yeah.
They also cite studies reporting positive effects on brainwave coherence and even reduced biological age based on glycan age studies, those measure biological markers linked to aging. The effects reported really span diverse biological systems.
And the applications go beyond just human health optimization, too.
Yes, sources highlight significant claimed benefits in agriculture, things like increased soil bacterial diversity, improved drought resilience in plants, enhanced vitality, higher yields.
And less need for chemicals.
Exactly. Reduced need for pesticides and fertilizers, even suggesting reduced water consumption. These practical implications point towards potential environmental and economic advantages, too.
So the insight here seems to be a focus on water as maybe an information medium, achieving a coherent state through a specific, lengthy, natural process, and the reporting of effects across diverse systems, backed by some studies using more rigorous designs like that double-blind placebo control.
Exactly. That level of reported rigor, as cited in the material, does lend a certain credibility to their findings, distinguishing it perhaps from more purely speculative claims we might discuss later.
Now let's look at Robert Slovak. His background is fascinating because it starts so firmly in conventional water treatment.
Yeah, he's described as an international water expert, over 40 years of experience, a real pioneer in reverse osmosis, or RO, development way back in the 1970s. He co-founded major water companies, really impacted how we purify water conventionally in homes and labs.
And then his focus shifted towards these alive water concepts. How did that happen?
Well, his career shows this evolution, moving from purely physical purification methods like RO to embracing concepts where water quality goes beyond just contaminant removal towards biological efficacy. He recognized that while RO delivers extreme purity,
It takes everything out.
right, it also removes beneficial minerals, which led to this perception of dead water.
His innovations include pioneering home and office RO systems and systems for medical applications like hemodialysis.
And then his focus shifted again into nutraceuticals related to water. He's really championed molecular hydrogen, H2, citing over 800 health studies on its potential benefits, and those studies are increasingly recognized in mainstream science. He co-developed the first reactive hydrogen tablet.
Interesting. And deuterium-depleted water.
Yes, DDW. He has a long-standing interest there, too. It's gaining renewed attention for its proposed health benefits, though the research on DDW is still maybe more nascent compared to the body of work on H2.
This approach, focusing on specific molecules like H2 or deuterium levels, seems quite different from the more abstract structuring claims we just discussed with Laraker.
It does, yeah. Slovak's work with molecular hydrogen and DDW involves specific molecular modifications or additions to water for targeted biological effects. This aligns much more closely with conventional biochemistry, identifying specific active ingredients like H2 rather than relying solely on a less defined concept of structure or coherence.
So maybe a more direct pathway for scientific validation.
Potentially, yes, through established biological mechanisms.
Okay, moving on to Max Langenberg. The source describes his approach as highly integrated, pulling from physics, engineering, biochemistry, even quantum field theories. That's a wide net.
It is. Langenberg has apparently been researching water for over 40 years, leading to Langenberg Technologies. His product, Langenberg Oxygen Water, was initially medical grade in Germany. Sources claim exceptionally high purity, reducing contaminants to essentially zero, and its pH balance to an optimum of approximately 7.7.
They also mention it contains optimally balanced essential minerals, like Slovak's point about RO. But what about the unique properties he claims? That's where it seems to diverge.
That's where it gets really interesting and, yeah, specific. A key claim is optimized microcluster size, aiming for what they call monomolecular levels, the idea being incredibly small clusters for maximum hydration and minimal interactions between water molecules.
On a molecular level, so it
Yeah,
sounds extreme.
it does. The water is also claimed to contain high levels of stable monoatomic oxygen and other forms, O2, O4, O5, O6, O7, plus monatomic platinum group elements.
Stable monoatomic oxygen and platinum group elements in water. These sound like very specific and unusual claims compared to others we've heard.
They definitely differentiate his approach. And the purported biological effects linked to these are things like accelerated metabolic rate and physiological response. It's also claimed to enhance neural ability, acting like a superconducting antenna for subtle energy fields. And the monatomic platinum group elements are said to accelerate brain response and immune function.
And his work connects to large-scale applications too, right? Something about waste-to-energy technology.
Yes, that's mentioned. Langenberg Technologies has apparently developed WTE technology that converts waste into electric power, drinking water, and fuel, purifying the water to medical grade in the process. This shows a vision extending beyond just individual health optimization to addressing these huge global challenges in energy, waste management, clean water supply, linking these maybe esoteric water properties to large-scale industrial applications.
So the insight with Langenberg is that multifaceted approach combining extreme purity, specific minerals, these unique claimed components like monoatomic oxygen, and linking it all to a vision for solving large-scale global challenges.
Absolutely. It's definitely a blend of the micro and the macro there.
Next, Dick Wohlert and WET, focusing on what they call IP water, or ion product water.
Their core technology utilizes water electrolysis, described as a hydration machine, patented in Japan and the US.
Okay, electrolysis is a specific, well-defined process. What does their technology claim to achieve that's different?
Well, this machine is claimed to produce functional water with significantly higher energy, they call it IP or ion product, than tap water or even existing electrolyzed water. Sources claim it produces twice the hydrogen and oxygen compared to other electrolysis methods.
Interesting. And the pH?
Sources note it's claimed to have a neutral pH, which is a bit unusual because, as we might touch on later, electrolyzed reduced water, ERW from electrolysis, is typically alkaline, so that's a point of potential clarification.
And reported effects. What does the science say?
Scientific studies are reportedly shown to demonstrate that IP water improves cellular hydration. So again, it's using a specific reproducible method to alter water properties and reporting a measurable biological effect.
And it has practical applications, particularly in agriculture. That seems to be a theme.
Yes, sources note it's proven to reduce foodborne pathogens on produce, minimize dependence on chemical pesticides, fungicides, and fertilizers, strengthen plant structure, improve rejuvenation after adverse weather, and increase yields. So yeah, it suggests a versatile technology with tangible benefits in agriculture as well as potentially human hydration.
So the insight here is using a specific reproducible method like electrolysis, aiming for tangible biological effects, potentially making it more amenable to direct scientific validation than some of the more abstract concepts, and its broad utility.
Right. So we've explored these pioneers whose work involves specific processes and technologies, some with imported studies following what seem like rigorous designs, and some with claims that definitely start sounding quite a bit different from established science.
And that brings us squarely to the next major section of our deep dive, examining some of the more unconventional theories and the significant scientific critiques they face, as detailed very clearly in our source material. This is where the landscape gets, well, more complex and certainly more controversial. Let's start with Dr. Gerald Pollack, a professor of bioengineering, and his work on exclusion zone, or easy water.
Okay, Pollack proposes what he calls a fourth phase of water, distinct from solid, liquid, and gas. He claims it forms spontaneously right at hydrophilic surfaces, surfaces that water likes to stick to.
What are the observable properties of this easy layer in his lab experiments? What do they actually see?
Sources list several key things. It's described as having a highly organized, almost gel-like structure. It's apparently slightly negatively charged, which allows it to repel impurities, hence the nickname superwater sometimes. And it seems to have the capacity to store and transfer energy, especially from light like infrared or sunlight, which he says promotes its formation.
And it pushes things out.
Yes, it forms this semi-solid layer near the hydrophilic surface that physically excludes microscopic particles. That's where the exclusion zone name comes from.
And he proposes a specific molecular formula for this state.
Yes, he proposes H3O2.
Okay, H3O2. That sounds different. What about its proposed roles in biology? That's the key link.
Pollock posits that easy water is fundamental for cellular function and hydration. He suggests that the water within our cells is actually structured and gel-like, not just bulk liquid water. He has this water battery concept.
A battery.
Yeah, proposing the negative charge of easy water as a primary source of cell potential, offering an alternative, or maybe a supplement, to the standard understanding of membrane pumps driving things. It's also linked to a concept of human photosynthesis, powered by light, enhancing nutrient absorption, detoxification, and even providing a potential mechanism for blood circulation beyond just the heart pump.
There's a lot of big claims.
Yeah.
And potential tech applications mentioned.
Well, it's seen as inspiration for devices attempting to structure water things using vortexing, light, crystals, magnets. It could provide a basis for the benefits seen in infrared therapies. Potential agricultural uses are mentioned, and even a really speculative idea for high-capacity computer memory where the EZ structure could somehow encode information.
Okay, so those are the claims and proposed implications from Pollock's work. But the source material also provides a really crucial look at the scientific community's reception and the significant critiques. This part is important.
Yes, and this is vital to understand the nuances here, because the reception is described as this complex dichotomy. On one hand, the phenomenon itself, the exclusion zone, the actual observation of particle repulsion from hydrophilic surfaces that has been independently replicated by multiple research groups, it's described as a genuine physical phenomenon that does require explanation. So the effect is observed, it happens in the lab.
But the explanation for the effect, Pollock's theory, faces strong critique.
Exactly. His theoretical explanation for why this happens, particularly the proposed H3O2 formula, and the idea that this stable structure extends hundreds of microns from the surface, faces substantial criticism from mainstream chemistry and physics. Sources note the H3O2 formula is considered chemically impossible under normal conditions, requiring immense energy, and would result in unrealistic charge concentrations compared to the small pH changes actually measured near surfaces.
And they draw parallels to a historical controversy, something called polywater.
Yes, strong parallels are drawn to the polywater controversy back in the 1960s and 70s. That was a case where anomalous water properties observed near surfaces were ultimately attributed to impurities, not some new phase of water. Critics suggest Pollock's proposed structure seems even more improbable and stable than polywater was claimed to be. Skepticism also arises from the methodology inferring a complex molecular structure from macroscopic observations. And, perhaps inevitably, the perceived association with water memory, even though Pollock himself doesn't explicitly claim intelligence or memory in water, likely contributes to wariness in some scientific circles.
Are there alternative explanations proposed for the observed particle exclusion phenomenon?
Yeah.
Ones that fit better with current science?
Yes. A compelling alternative discussed in the sources is diffusiophoresis. This theory, which is driven by ion exchange and concentration gradients near surfaces, offers an explanation for particle exclusion, and its predictions have reportedly been experimentally confirmed by other researchers. It's a more conventional physics explanation.
So it could just be ions moving around.
Essentially, yes, concentration gradients driving particle movement. Conventional interfacial water effects near surfaces are acknowledged in physics, but they're typically very short range, like nanometers, not the hundreds of microns claimed for EZs. Plus, potential confounding factors in the experiments, like charged surfaces or dissolved gases forming nanobubbles, are also noted as needing extremely careful control.
So the controversy around Pollock isn't really about whether something interesting happens near a hydrophilic surface, but what exactly is happening and how it's happening. The interpretation is the key issue.
Precisely. It's about the interpretation and the mechanism of the observed phenomena. Sources mention Pollock frames it as a potential paradigm shift, and they also note that continued funding, including NIH transformative grants which are specifically for high-risk, potentially paradigm-shifting research, suggests his observations are intriguing enough to warrant further investigation, despite the significant theoretical heterodoxy. The field is actively grappling with these anomalies and observed effect with a mechanism that is still very much under intense debate.
Okay, let's move on to John Ellis Water. The source material describes his process as fundamentally a distillation system. It has recirculation, a boiler, condenser, UV light.
Yes, and the patent itself seems to focus on pretty standard water purification aspects, degasification, contaminant removal, producing hot distilled water, minimizing foam. UV light is included for disinfection, which is, a standard validated method for killing microbes. Recirculation is just a standard engineering approach for efficiency in distillation systems, nothing too unusual there.
But the source material is very, very clear that the promotional claims go way beyond this standard process.
Absolutely. This is where the critical analysis in the source material focuses, and it's quite sharp, frankly. Promotional claims include things like rapid heating and cooling or the Faraday-Ellis method, which is claimed to restore energy. And here's the really big one: permanently change water's fundamental bond angle to 114 degrees.
Permanently change the bond angle from the established 104.5 degrees. I mean, that sounds like changing the molecule itself, fundamentally.
It is. The source material directly calls this claim scientifically absurd. Changing the fundamental HOH bond angle to 114 degrees is just chemically impossible without changing the water molecule's identity itself. Based on everything we know from established physics and chemistry, it wouldn't be water anymore. It's not a subtle structural change. It would have to be a different substance entirely.
And the claims of verification by prestigious institutions like Los Alamos or Lawrence Livermore.
Sources state these are false claims, period. There is absolutely no evidence from Los Alamos Nuclear Lab, Lawrence Livermore National Lab, or Dr. Guy Abraham at UCLA using a scanning electron microscope as claimed. The technical misuse of the sum here is highlighted as strong evidence of pseudoscientific claims. A scanning electron microscope is for high-resolution surface imaging. It's not a tool for measuring intramolecular bond angles in liquid water. It's just the wrong tool for the job being claimed.
What about other claims mentioned, like charged water or multiple forms of oxygen or hydrogen existing within the water?
Those are also debunked quite clearly in the source material. Adding excess electrons to water, charging it, would simply cause it to decompose through electrolysis. Claims of multiple allotropes, different structural forms of oxygen or hydrogen existing stably within liquid water, are just inconsistent with established chemistry and physics.
And the pH 7.7 claim.
That claim that pH 7.7 is somehow uniquely ideal for human health also lacks direct scientific substantiation. Sources point out that pH 7.7 is relevant in some completely unrelated fields, like preventing aluminum accumulation in municipal water pipes or optimizing the efficacy of certain herbicides. But the human body has incredibly robust pH regulation systems, especially in the blood. It makes the idea that drinking water pH has a significant systemic health impact highly unlikely, according to scientific consensus.
So the significance here isn't just theoretical speculation or debatable mechanisms like with Pollack, but demonstrable scientific falsehoods and, crucially, false claims of institutional verification.
Correct. The source material explicitly links this pattern to marketing practices that have actually led to regulatory intervention and consumer protection issues. It's very clearly distinguished from other areas of legitimate water science or, importantly, the work of other notable people who happen to be named John Ellis. This case seems to fall squarely into a category of outright scientific misrepresentation.
Let's turn now to Dr. Mei-Wan Ho. She was originally a geneticist, but the sources note her later work became more associated with critiques of mainstream science and organizations like the Institute of Science and Society, or ISIS.
Yes, and ISIS is noted by watchdog groups like Quackwatch as questionable. It has published on topics widely considered fringe, including things like homeopathy and this concept of water memory. Ho herself was a vocal critic of neo-Darwinism and published extensively on quantum coherence, liquid crystalline water, and what she called coherent domains in water.
What was her core concept regarding water specifically?
She posited these coherent domains existing in water, which she saw as a source of almost free electrons, vital for biological redox reactions and energy transduction. She viewed interfacial water, similar to Pollack's easy water, as a giant coherence domain. Her theories relied heavily on specific, sometimes unconventional interpretations of quantum mechanics.
And she was strongly associated with water memory.
Very much so. A core concept is water memory, the idea that water can retain information or a memory of substances dissolved in it even after extreme dilution, essentially providing a theoretical underpinning for homeopathy. This was linked to ideas like DNA imprinting its structure or chirality onto the surrounding water, creating a hydration fingerprint or even a macroscopic superstructure.
And the scientific scrutiny on her work, how was it received?
It's described as strongly negative within mainstream science. Sources note her work is widely considered pseudoscience, partly due to its strong association with homeopathy, which lacks scientific validation, and the connection to ISIS being listed on Quackwatch. Critics state her theories contradict fundamental principles because there's just no robust empirical evidence for stable, long-term information retention in bulk water, It violates established physics and chemistry.
The memory decays too fast.
Exactly. Any vibrational memory in water decays in picoseconds far, far too fast for any meaningful, lasting memory of the type required for these theories. Claims of defying thermodynamics are also seen as extraordinary and lacking the necessary extraordinary evidence.
So her theories represent a really significant divergence from mainstream physics and biology.
Hugely significant. Critics argue her extrapolation of quantum principles to macroscopic biological phenomena lacks empirical backing and makes her theories very difficult to test or falsify using conventional scientific methods. So the skepticism stems primarily from this lack of empirical validation, methodological concerns, and the strong association with fringe science, distinguishing the critique of her work from cases involving, say, documented fraud or verifiable false claims.
Okay. Finally, in this section, Dr. Shuyin Lo, the sources present a particularly severe critique of his work, maybe the most severe.
Yes, his theories involve concepts like IE crystals and stable water clusters, which he commercialized and marketed as double helix water. The critique outlined in the sources is explicit and includes findings of documented fraud. Sources state flatly that his core theory explicitly violates fundamental laws of thermodynamics, according to expert analyses.
And independent tests of his claims. Did anyone try to replicate them?
Yes, and they reportedly failed entirely. Independent labs, using standard scientific techniques like transmission electron microscopy, TEM, and UV spectroscopy, found his claimed IE crystals were completely indistinguishable from ordinary tap water. They simply weren't there when others looked.
And regulatory bodies also weighed in on Lo's work.
They did. The Oregon Attorney General's office, after investigation, concluded his experiments were, quote, worthless due to lack of proper controls, and his claims directly contradicted accepted science. There's also mention of a British physicist who was funded by Lo's company to study the water, reported largely negative results, dismissed the claims as scientifically unsound, and apparently faced pressure from Lo's company to alter his findings.
Wow.
Internal contradictions were also reportedly found within Lo's own published papers.
And this is directly tied to commercial fraud, not just questionable science.
Directly tied, according to the sources. His work and theories were linked to commercial products like a laundry solution and an engine additive that were legally deemed fraudulent by regulatory bodies like the U.S. Federal Trade Commission, FTC. His later ventures reportedly continued to make similar unsubstantiated claims.
So, the significance of Lo's case, as presented in the sources, is really direct scientific refutation by independent labs, failed independent verification, documented instances of commercial fraud, and formal regulatory intervention. This clearly represents a category of scientific misconduct and misrepresentation, quite distinct from the theoretical debates around Pollock or the more speculative fringe associations of Ho.
Absolutely. It's critically important to differentiate the nature of the critiques and controversies surrounding these different figures. You have genuinely observed phenomena with debated explanations, like Paul XEZ. You have speculative theories lacking validation and linked to fringe ideas, like Ho's. And then you have cases involving outright scientifically false claims coupled with documented commercial fraud, like Lo and Ellis.
Okay, let's quickly summarize the unconventional theories and where they might overlap or diverge, both in their claims and the critiques they face. It seems like there are some shared themes.
There definitely are shared things among Ho, Lo, and Ellis especially. They all, in different ways, propose that water can exist in these unique, stable, structured forms, whether it's called liquid crystalline, coherent domains, i.e. crystals, stable clusters, hexagonal structure, or H3O2. These forms are claimed to be significantly different from the dynamic baseline of liquid water.
And they all link these structures to big health claims.
Right. They attribute extraordinary health and biological properties to these structures, linking them to fundamental aspects of physiology, energy, healing, and sometimes explicitly to alternative medicine concepts like water memory. All of them in some way challenge conventional physics and biology, often invoking fundamental shifts in our understanding of water's role in life.
It seems this whole area, perhaps because water is so fundamental and maybe still holds mysteries, taps into a deeper curiosity, or perhaps even a desire for simpler, unifying explanations for complex health issues.
That observation is certainly noted in the sources, that cultural or philosophical appeal. However, the receptions of their work contrast sharply, which is the key takeaway here. Ho is critiqued primarily for the philosophical and speculative nature of her work, a perceived lack of empirical rigor, maybe over-extrapolating quantum ideas, and that strong association with fringe pseudoscience like homeopathy and ISIS.
Whereas Low and Ellis.
They faced much more direct refutations based on established physics, failed independent tests specifically designed to replicate their core claims, and crucially documented fraud or deception related to their commercial products. Ellis specifically with those false claims of verification and the blatant technical misuse of scientific terms and tools like the SIM. The FTC warnings and regulatory interventions are major red flags.
So Ho's divergence is perhaps more about methodology and speculative interpretation operating outside the mainstream, while Low's and Ellis's cases involve demonstrable scientific falsehoods and serious commercial issues leading to regulatory action.
Correct. Understanding this distinction, the type of critique is absolutely key to evaluating the scientific landscape in this often confusing area. It's definitely not a single monolithic block of unconventional water science, but a real spectrum with vastly different levels of evidence, credibility, and types of criticism involved.
Okay, now let's shift gears completely. Moving away from the critiques and controversies, how could some of these ideas, particularly the more promising or scientifically intriguing ones, combined perhaps with established science, inform the actual design of truly advanced water systems? What might that look like?
Well, the source material really envisions a potentially transformative approach here, not just thinking about a filter, but designing a kind of holistic health engineering system. The goal would be to go beyond conventional purification to make water biologically active and maybe optimally structured, drawing from all these different threads.
What would be some key modules or concepts in such a hypothetical system based on the outline and sources we have?
Okay, it has to start with the absolute foundation, foundational purity and biocompatibility. This means going beyond even standard filtration like RO, which we know can strip everything out. Sources suggest using advanced distillation techniques, maybe next-gen systems like HSDWE or low-temp vacuum distillation for truly superior contaminant removal. We're talking heavy metals, PFAS, pharmaceuticals, all the really difficult stuff.
Addressing that dead water perception head on.
Exactly.
Yeah.
But critically, immediately after achieving that ultra purity.
You have to put things back in.
Precisely. Sophisticated remineralization. This is crucial not just for taste, but for pH balancing, maybe aiming for slightly alkaline, say pH 8 to 9.5 for bioavailability, and restoring a natural, balanced mineral profile, perhaps similar to renowned natural springs like those in Hunza or Nordenau.
Because pure demineralized water isn't ideal long term.
Right. Sources emphasize that while dead water is a subjective term, the lack of essential minerals and the potential slight acidity of pure RO or distilled water is a genuine consideration for long-term consumption. Remineralization addresses this directly, providing essential minerals the body actually needs, like calcium, magnesium, potassium, maybe strontium, in a form it can use.
Okay, so purify to the absolute max and then carefully rebuild it with natural minerals for biocompatibility. What's next in this ideal system?
Targeted molecular enhancement. This is where we bring in specific beneficial molecules. For example, integrating technology like electrolysis, specifically designed to generate high concentrations of dissolved molecular hydrogen H2.
Which has growing research behind it.
A lot of research, yeah. Sources call H2 a cornerstone because this growing body of work, even in mainstream science, points to its benefits in optimizing cellular metabolism, mitochondrial function, ATP production, and acting as a selective antioxidant only targeting the harmful radicals. You'd also want to optimize dissolved oxygen O2 levels.
And nanobubbles fit in here. I remember seeing that mentioned.
Yes, crucially. Integrating nanobubble technology is mentioned specifically for enhancing the stability, bioavailability, and longevity of these dissolved gases, H2 and O2, in the water. This helps ensure the beneficial molecules actually stay in the water longer after it's dispensed from the system.
Makes sense.
And don't forget, the electrolyzed reduced water, ERW, produced during electrolysis often has its own potential benefits, like antioxidant properties due to the negative ORP and the alkaline pH, which could potentially add synergistically to the overall effect.
So we've purified, remineralized, and added specific beneficial molecules like H2 and O2 using stable methods. What about incorporating some of the more, let's say, frontier concepts we discussed earlier, the structural or energetic ideas?
That leads us to what the sources conceptualize as an energetic infusion chamber. This module represents the integration of more speculative frontier elements based on some of the theories we covered. It could potentially include things like sound or frequency infusion.
How'd that work?
The idea is that water passes through a chamber where specific frequencies are applied, perhaps drawing inspiration from research areas like aquaphotomics, which some sources suggest show measurable effects on water's hydrogen bonding network, structure, and stability based on exposure to specific light or sound frequencies. Like 432 hertz is sometimes mentioned.
But the source material also mentioned using voice spectral analysis here and added a pretty strong caution.
Yes, and that's really important to reiterate. While the idea exists in some alternative health approaches, analyzing someone's voice for dropped out frequencies and then infusing those specific frequencies back into their water for targeted health outcomes, the sources explicitly state this is largely anecdotal, highly theoretical, and lacks robust validation in mainstream science. It definitely touches directly on that controversial concept of water memory, carrying specific energetic information, which is scientifically unproven.
So, handle with care. What else might be in this hypothetical energetic infusion chamber based on the concepts we've covered?
Well, maybe scalar energy field generation. The concept involves a generator creating a specific type of non-electromagnetic field, a scalar field, around the water. This is theorized in some of these frontier concepts to restructure water, enhance cellular resonance, positively influence bioenergetic fields, improve cell communication, and boost mitochondrial activity. Again, it's crucial to stress. Sources clearly note these are theoretical emerging claims that require significant further investigation and validation.
Okay. Then perhaps a final stage before the water is actually delivered or consumed.
Yes, a final structuring and delivery module. This could involve methods like vortexing the water or exposing it to specific wavelengths of light like UV or particularly infrared just before consumption. These methods are believed by proponents, potentially linking back to Pollack's observations about easy water, to promote easy water formation or enhance its stability, with the goal of improving cellular hydration and absorption.
So the overall synergy of this hypothetical multi-stage system, what's the intended outcome?
The vision described is really a layered approach. It aims to potentially promote structured water, maybe something easy-like, through multiple potential pathways working together. The inherent structure possibly provided by colloidal minerals from the remineralization step, the effects of electrolysis potentially creating ERW, and maybe the influence of these sound or scalar fields in the energetic chamber. The ultimate goal is to optimize water chemically, purity, minerals, molecularly H2, O2, and perhaps energetically, based on this broader, more controversial idea that water can carry energetic signatures or information, connecting back to concepts like water memory or coherence.
And there are other even more cutting-edge, maybe even further out emerging concepts mentioned briefly in the sources for potential future integration, things even more speculative.
Briefly, yes. The sources list a few things that are even deeper in the speculative realm or represent very early research areas. Things like magnetically structured water, looking at the influence of magnetic fields on water's structure and properties. Quantum entanglement applied to water, a highly speculative idea about imprinting subtle information via coherent quantum fields, using terahertz radiation, which interact interestingly with water and biomolecules, perhaps as a way of tuning water's vibrational states.
Wow.
And even concepts like AI-driven adaptive personalization. Imagine using real-time biometric data from wearables to dynamically adjust all the water parameters, minerals H2 frequencies, for an individual. Or engineering harmonic resonance cavity-specific chambers designed to create stable resonant fields that might impart stable energetic signatures to the water or promote cellular self-organization. But again, sources explicitly note these are very much frontier concepts needing significant, rigorous research before any claims can be made.
And personalization seems like it could be a major factor, too, down the line if any of this proves out.
Absolutely. The Envision system includes a modular design specifically to allow for integrating new technologies as they emerge and are validated. And yes, the potential for user-specific programming, tailoring the water's properties based on individual needs, is a key future direction if the supporting science and diagnostic tools emerge. The idea of eventual integration with wearables for real-time feedback and optimization really points towards a highly personalized future for hydration should these concepts mature.
This definitely paints a picture of a highly advanced, maybe even futuristic system. It's built on this blend of increasingly validated science like H2 and these highly speculative frontier ideas about structure and energy.
And that brings us right back to the challenges inherent in this entire field, the critical need for rigorous validation and thinking about potential future directions realistically.
So what's the final recap, then, of the complex landscape we've explored today?
It's really a landscape rich with innovative claims, some genuinely intriguing empirical observations reported in labs, and alongside that, very significant and often necessary scientific skepticism. There's this real disparity you see throughout the sources. On one hand, you have studies reported, sometimes with robust designs like double blind placebo control, showing positive outcomes for specific interventions. On the other hand, there's this broader skepticism citing the lack of large scale independent replication for many claims, the absence of scientific consensus on the very existence of stable macroscopic water structures under physiological conditions, and often a critical mechanism gap.
Meaning we might see an effect, but we don't really know how it's happening.
Exactly. Effects might be observed or claimed, but the how at a fundamental chemical or physical level is often unclear, disputed, or relies on theories outside the mainstream.
So what's needed for this field to progress responsibly and gain wider scientific acceptance where it might be warranted?
Rigor. Rigor is paramount. Sources consistently call for clear, standardized definitions and reliable measurement methods for describing properties like coherence or structure. We need identification and use of validated biomarkers to objectively measure key biological outcomes. Widespread, independent replication studies are absolutely crucial to confirm findings from different labs using different setups. And critically, there's a huge need for clear elucidation of mechanisms bridging that gap between the proposed changes in water state, be it structure, H2 content, whatever, and the observable cellular and systemic biological effects. Cytosolve, that computational biology platform, is mentioned as one potential tool that can help model these complex biological effects and maybe accelerate R&D in a more systematic way.
And whenever you're talking about things that could potentially impact health, ethical considerations are also vital, right?
Absolutely critical. The sources bring up several key ethical points here. Transparency is essential, clearly distinguishing between established benefits supported by robust evidence, like increasingly for molecular hydrogen, versus speculative theories or preliminary claims that require significant further research. Safety is non-negotiable. Rigorous testing and long-term studies are crucial, especially for any novel water treatments claiming health benefits. Accessibility and affordability are also important considerations if these technologies are ever meant to have wider societal impact. And regulatory adherence.
Following the rules.
Yes, not just adhering to existing standards for water quality and health claims, but potentially actively participating in helping to develop appropriate evidence-based standards for water composition and health claims specifically within this emerging complex field.
So the future outlook for this field overall,
Yeah.
it's mixed.
It seems to be. It's presented as a field with components that are increasingly being validated through conventional scientific methods, things like H2 infusion, advanced purification techniques, the importance of remineralization. These exist alongside these frontier areas, the mechanisms behind EZ water, energetic infusion concepts, quantum effects, structure claims that require extensive, rigorous scientific inquiry before any firm conclusions can be drawn. It's definitely portrayed as an exciting but incredibly complex area of exploration that demands a critical, open-minded, but ultimately highly scientific approach to separate what might be truly groundbreaking from what remains unsubstantiated theory or, in some cases, outright misinformation.
So we've journeyed today from the fundamental, universally accepted science of HO through the really intriguing work of pioneers exploring water's potential biological impacts in new ways, then into some highly controversial theories and the sharp critiques they face, and finally to the vision for what a truly next-generation water system might encompass.
What really stands out from reviewing all this material, I think, is that water, despite being so incredibly familiar and seemingly simple, might still hold secrets we're only just beginning to truly explore. We see robust science showing specific interventions, like adding molecular hydrogen, can indeed have measurable effects on biology. And then right alongside that, we have these concepts like water carrying complex information or having stable, long-lasting, energetic structures that fundamentally challenge our current understanding of physics and chemistry and face really significant scientific hurdles.
It's a powerful reminder, isn't it, that in any frontier area of science, the line between potentially groundbreaking discovery and unsubstantiated claims can sometimes feel incredibly blurry. It underscores the absolute necessity for rigorous, reproducible science, especially when health benefits are being claimed. Evaluating the quality of the evidence and understanding the nature of the critique, is it a theoretical debate among experts, or is it based on failed replication or even documented falsehood? That's just crucial for navigating this space.
Absolutely. This deep dive really shows us that thinking about water quality might need to evolve beyond just removing contaminants. It could potentially involve considering its molecular composition, like H2 levels, its mineral balance, maybe even its physical structure or energetic state, and how all of that interacts with our biology in ways we're still actively trying to figure out. But separating what's genuinely promising and backed by evidence from what's simply speculation or worse, deliberate misrepresentation requires a really critical and discerning eye from all of us.
Which really raises an important final question for you, our listener, to ponder. As research inevitably continues to push these boundaries, potentially validating some of these frontier concepts while maybe definitively debunking others, what role do you think these unconventional ideas about water will ultimately play in shaping our understanding of health and hydration in the future? Beyond just being clean and properly mineralized, what aspects of water are you most curious to learn more about?